Good morning, students. Let us continue the Unit 3 part of Engineering Mechanics, that is called Centroids and Center of Gravity. In the previous class, we have discussed about determination of centroids by composite figures, determination of centroids by simple figures, and the third one, as I told you the other day, that centroids by shaded regions. Let us do some problems on this centroids by shaded regions. If you see the problem 1 followed by the determination of centroids by shaded region, find the centroid of shaded region in the following figure. When we are going to receive the problem like this, the first thing what we have to do here is, we have to apply this diagram into the symmetric property. Before we are going to that, let us check that this diagram is coming under composite figure, or this diagram is coming under simple figure, or this diagram is coming under shaded region. So, as I told you that the determination of centroids is by 3 types, 3 categories. And this diagram is completely coming under the third category, which is called determination of centroids by shaded regions. If you see this diagram, this is a rectangle consisting 2 composite figures, and out of the 2 composite figures, one part of the composite figure is shaded. So, first of all, what we have to do here is, we just apply the symmetric property to this diagram. I am applying here, look at carefully like this. The first properties to apply the symmetry property like this. This is called y axis and this is called x axis. So like this we have to apply the symmetric property to this diagram. Once you are going to apply the symmetry property to this diagram, now we are going to split this shaded region consisting composite figure into 2 categories. Let us consider, let me derive this particular formula, that is called, this is called first portion and this is called second portion. So, if you see the first part is called rectangle and the second part is called quarter circle. As I told you, the determination of centroids by different standard figures, and out of the figures like circle, semicircle, quarter circle, if you see this particular portion, this is completely quarter circle. I am considering this quarter circle as the second portion and the total rectangle is considered as the first portion. Okay, let us do this problem by applying symmetry property. So, let me tell you this particular property here. If you apply the symmetry property to this diagram, we came to one conclusion. What is that? You know, the given composite figure consisting shaded region is not symmetric to any of the axes. Then what we have to do? We have to find both x bar and as well as y bar. As I told you that the centroid of shaded region given by the following figure, if the composite figure is consisting 2 portions, we need to find a1 x1, a2 x2, a1 y1, a2 y2, and after that the utilization of a1 x1, a2 x2, we find x bar, and the utilization of a1 y1 and a2 y2, we find y bar. Let us see this from the following figure. The given figure is divided into 2 parts, as the given section of the composite figure with the shaded region is not symmetric to any of the axes. So, when the given section is not symmetric to any of the axes, we need to find both x bar coordinate and y bar coordinate. Suppose, if this given composite figure consisting with shaded region is divided into 2 parts, let us going to divide these 2 parts as the part 1 is called rectangle and the part 2 is called quarter circle. So, how to find the areas belonging to both rectangle portion and quarter circle portion? If we see the first one, looking to the diagram, my A1 is equal to L into B, because my first portion is rectangle. To find area of a rectangle, we have a standard formula that A1 is equal to L into B. In the diagram, if you see, my L is equal to 30 centimeters and my B is equal to 20 centimeters. Therefore, my A1 is equal to 600 centimeters square. Then we need to find the x1 coordinate and y1 coordinate. As I told you that there is a standard procedure to find the coordinates of x1 and y1, that in all the 3 categories of simple figures, composite figures and shaded regions, to find all the x coordinates, we need to move from left hand to right hand direction, and to find all y coordinates, we need to move from downwards to upward direction. So therefore, if you see x1 is equal to L by 2, for example, for finding the first coordinate x1, as my length to find area here is 30 centimeters, bringing length to here and dividing with the 2, you will get 15 centimeters. Therefore, my x1 is equal to L by 2, that is equal to 30 by 2, that is equal to 15 centimeters. Similarly, if you take y1 coordinate, y1 is equal to b by 2. As my first portion is rectangle, my b is equal to 20 centimeters here. Bringing it and substitute it there, y1 is equal to b by 2, that is equal to 20 by 2, which is equal to 10 centimeters. Okay, similarly, come to the part 2, that is quarter circle. We have a standard formula to find the area of a quarter circle, that A2 is equal to pi r square by 4. In this formula, my r is representing that radius of the quarter circle. Bring the value of r, that is how much? 5 centimeters from the diagram. Therefore, A2 is equal to 3.14 into 5 whole square by 4, that is equal to 19.625 centimeters square. Okay, so this is A2 here. So my A2 is equal to 3.14 into radius 5 whole square by 4, that is equal to 19.625 centimeters. And if you are going to get the second coordinate x2, here we have to remember one thing here. As I told you that my x2 is the second coordinate of a portion called quarter circle. Before that, I have one more portion which is called rectangle. Then what I have to do here, x2 is equal to my second portion of the second coordinate x2 is equal to 30 minus 4r by 3 pi. So if you subtract this 4r by 3 pi from length of the first portion, that is x2 is equal to L minus 4r by 3 pi, I could write it as x2 is equal to 30 minus 4 into my radius is 5 divided by 3 into 3.14, and after simplifying the whole term here, I will get my x2 is equal to 27.87 centimeters. Now what we have to do? Using x1, y1, we find a1, x1, and using x1, y1, we find a1, y1. So in the part 1. Similarly, in the part 2, we have to find a2, x2, and after finding y2 coordinate, we need to find a2, y2. Let us see this. A1 x1 is equal to 600 into 15, that is equal to 9000 centimeter cube. Bring the value of x1, multiplying with A1, that is area of a rectangle in part 1. We will get A1 x1 is equal to 600 into 15, that is equal to 9000 centimeter cube. Similarly, A1 y1 is equal to 600 into 10, that is equal to 6000 centimeter cube. Now, what we have to do here is, after finding A1 x1 and A1 y1, this A1 x1 is completely belonging to the first portion, that is shaded portion. In the rectangle, there were two portions, as we observed in the diagram, that my A1 x1 is completely shaded portion, belonging to shaded portion. A1 y1 is the remaining portion, that is which is not shaded by the portion. Therefore, to find x coordinate, I should subtract the not shaded region from shaded region. You understood here? So, this A1 x1 is completely shaded region and A2 x2 is not shaded region. Therefore, I should find x bar is equal to A1 x1 minus A2 x2 by A1 minus A2. Here in this particular case, I just want to remind one previous situation what we have did it in composite figures and simple figures. In simple figures and composite figures, to find x bar and y bar, we add the combinations, the continuation of the combinations. But here, if you see the diagram, in the rectangle portion, there were two categories. One belongs to rectangle and other second portion belonging to quarter circle. Which part is going to be shaded? That we consider as positive, and the not shaded region is considered as negative portion. Therefore, x bar is equal to A1 x1 minus A2 x2 by A1 minus A2, and bringing the relevant values of A1 x1 to here and A2 x2 the part 1 and bring it here 9000 minus 19.625 into 27.87. In this, this 19.625 is A2 and 27.87 is x2. Therefore, after simplifying with this calculator, we will get x bar is equal to 14.56 centimeters. Similarly, coming to the part 2, that is quarter circle, my y2 is equal to 20 minus 4r by 3 pi. As this r is representing the radius of the quarter circle, that is equal to y2 is equal to 20 minus 4 into 5 by 3 into 3.14. And after simplifying this, we will get y2 is equal to 17.87 centimeters. Now, bring the values of y1 and y2. We need to find y bar is equal to a1 y1 minus a2 y2 by a1 minus a2. Here in this particular case, we are finding y coordinate. The a1 y1 is the first portion and a2 y2 is the second portion. All 2's representing the second portion and all 1's are representing the first portion. Therefore, to find y bar is equal to a1 y1 minus a2 y2 divided by A1 minus A2 and substitute the relevant values of A1 Y1, A2 Y2 to here. I will get Y bar is equal to 6000 minus 19.625 into this 17.87 is the value of Y2 divided by A1 minus A2. That is equal to, after simplifying the total calculation, then we will get Y bar is equal to 9.73 centimeters. So strictly speaking that this X bar is equal to 14.56 centimeters is the X coordinate of the given following figure, and Y bar is equal to 9.73 centimeters, which is called the Y coordinate of the following given figure. Okay. Now, if you want to write the centroid of this particular part, the given following figure, we need to write like this: C of X bar comma Y bar is equal to C of 14.56 comma 9.73 centimeters. So this is what is known as my C of X bar comma Y bar is equal to C of 14.56 comma 9.73 centimeters is the ultimate centroid of the given shaded region, as the shaded region is consisting the two portions. The first portion is exclusively rectangle and the second portion is exclusively quarter circle. Okay. And after finishing this, we have completed three categories, my dear students. The first category is determination of centroids by simple figures. They are all nothing but L shape, I shape, T shape and inverted T shape that we have finished in the last class. And the second category is determination of centroids by composite figures. Each composite figure is consisting either rectangle with a circle, either rectangle with a triangle, either rectangle with a quarter circle. Like that we have completed. And the third category is determination of centroids by shaded regions. After finishing this, we are going to enter into the determination of center of gravity by some standard figures. Let us see that. Determination of center of gravity of some standard figures. Previously, we have discussed determination of centroids. Determination of centroids either through simple figures or through composite figures or through shaded regions. In three of the categories, we find only the two axes, that is x-axis and y-axis. That's one of the important points we have to learn, that here, what is the executive difference between centroid and center of gravity? Centroid is determination of finding with respect to two axes, that is two-dimensional. As I told you in the beginning class of unit 3, that is centroids and center of gravity, centroids coming under two-dimensional, whereas center of gravity is coming under three-dimensional. So, let us see some 6 standard figures, the center of gravity of some standard figures followed by, if you see this particular tabular form chart, that is serial number, name of the shape of the specimen, X bar coordinate, Y bar coordinate, Z bar coordinate and volume. As I told you in the beginning class that in all determination of centroids we find area. That means related to only two axes, that is X bar and Y bar, but determination of center of gravity is belonging to three-dimensional axis, that is X, Y and Z axis. In this particular thing, we need to find volume. So, our ultimate article is to find out the volume of center of gravity with respect to standard figures. If we see the first standard figure, that is called solid cylinder. Okay, bring the shape of solid cylinder. You need to be write it in three-dimensional axis, that is X-axis, Y-axis and Z-axis. So, in this particular area, if I draw the solid cylinder like this is called diameter from extending from here to here, and this is height extending from here to here. So, the standard formula of X bar coordinate of solid cylinder is d by 2, Y bar coordinate of solid cylinder is h by 2, and Z bar coordinate of solid cylinder is d by 2. And to find volume of this so-called solid cylinder, we have a standard formula which is known as pi r square h. Similarly, coming to the second specimen, my dear students, namely, this is called solid cone. Strictly speaking here, if you write the particular name here, solid cone, bring the solid cone and draw this diagram in this particular place. This is called solid cone. The way you have to draw solid cone in three-dimensional plane is like this. This is x-axis, this is y-axis, this is z-axis. So, in solid cone also, we have two parameters. One is diameter from here to here, other one is height. And to find x coordinate of solid cone is d by 2, y coordinate of solid cone is h by 4, z coordinate of solid cone is d by 2, and the volume of solid cone is 1 by 3 pi r square h. We have three pairs, my dear students. So, how to remember this 6 shapes of standard figures of center of gravity. You know, the first one is solid cylinder, second one is solid cone, okay, and the third one is solid sphere, fourth one is solid hemisphere. So solid sphere and solid hemisphere are very much nearer, very much comparable, and the solid cylinder and solid cone are very much comparable. Did you understood? So that is why I told you that the 6 standard figures of center of gravity is classified into 3 categories. Okay, the first pair is solid cylinder and solid cone. The second resembling pair is solid sphere and solid hemisphere. And the third resembling pair is solid cube and solid cuboid. That we will see. Okay. The third shape is solid sphere. This you have to written like this: x-axis, y-axis, z-axis. The diameter of solid sphere is represented like this. X bar coordinate of solid sphere is d by 2. Y bar coordinate of solid sphere is d by 2. Z bar coordinate of solid sphere is also d by 2. And to find volume of the solid sphere, my volume of solid sphere is 4 by 3 pi r cube. Similarly, coming to the fourth specimen called solid hemisphere. As I told you that these two are very much nearer. So solid sphere hemisphere is represented by like this. In this diagram, x, y, z axis, this from here to here is d. What is that? Diameter. And to find x coordinate of the solid hemisphere, d by 2. Y coordinate of solid hemisphere is 3r by 8. And z coordinate of solid hemisphere is d by 2. And volume of solid hemisphere is 2 by 3 pi r cube. We have to remember in the formulas and diagrams. So we have completed 4 solid specimens. What are they? The first one is solid cylinder. The second one is solid cone. And the third one is solid sphere. Fourth one is solid hemisphere. And we left 2 more standard figures. Those are called solid cube and solid cuboid. Let us draw this. If you see the fifth specimen called solid cube, it should be drawn like this. So strictly speaking, that in x, y, z plane, if we draw solid cube is like this, and in solid cube, both the 3 sides is supposed to be represented by the diameter like this. So my x coordinate of solid cube is d by 2, y coordinate of solid cube is also d by 2, and the z coordinate of solid cube is also d by 2. So if you want to find the volume of this formula, solid cube, that is around d cube. So standard formula to find the solid cube of this volume of solid cube is equal to d cube. And last specimen, which is also quite nearer to this, the fifth one is solid cuboid. Okay, if you draw this diagram in xyz plane, it is like this. There are 3 parameters. One is length, breadth, and height. Using these 3 parameters, we need to find the x coordinate of solid cuboid is L by 2, y coordinate of solid cuboid is B by 2, and z coordinate of solid cuboid is H by 2. So, to find the volume of this solid cuboid, the standard formula is LBH, L into B into H. Like this, my dear students, we have 6 standard figures, and with the utilization of these 6 standard figures, we need to find the center of gravity. As I told you that, the remembering point to determine determination of center of gravity is determination of center of gravity followed by these 6 figures is to be linked with the 3-dimensional axis. That is one of the important points. So, these 6 solid specimens, as the first one is solid cylinder, second one is solid cone, third one is solid sphere, fourth one is solid hemisphere, fifth one is solid cube, and the sixth one is solid cuboid. In all these 6 standard figures, our ultimate article is to find out x bar, y bar, z bar, and the utilization of x bar, y bar, z bar, we need to find volume. That is the difference between the determination of centroids and determination of center of gravity. So in determination of centroids, we find area. We will give more importance to area because it is belonging to the 2-dimensional axis. And coming to the determination of center of gravity, we need to find volume of every solid specimen, and we need to find x bar, y bar, and z bar. So strictly speaking, that determination of centroids coming under 2-dimensional, and determination of center of gravity is coming under 3-dimensional. Let us do one problem on this particular formulas. If you see the problem 1, determine the center of gravity of the following figure. That is, if you see this diagram, you need to identify that it is coming under which shape. So this is nothing but called solid cone. As I told you in the previous topics that the solid sphere, solid hemisphere, solid cone, and solid cylinder, if you look at this diagram, in this diagram is completely representing by the solid cone. First of all, what we have to do here is, in this solid cone, my diameter is 50 centimeters and my height is 100 centimeters. How to do this problem? First of all, from the given figure, we have to download the values like this. Given specimen is solid cone. The diameter is D is equal to 50 centimeters and height is equal 100 centimeters. Now, utilization of this D and H, we need to find the X bar, Y bar and Z bar. Then we find volume of this particular given solid cone. Okay. So, we have standard formula to find the X bar coordinate, Y bar coordinate and Z bar coordinate. Let us see this. My X bar is equal to D by 2. That is equal to 50 by 2, which is equal to 25 centimeters. And my Y bar is equal to H by 4. That is equal to 100 by 4, which is equal to again 25 centimeters. And my Z bar is equal to again G by 2, that is equal to 50 by 2, which is equal to 25 centimeters. So, as we have the standard formulas to find X bar, Y bar, Z bar of this given solid cone, we have respective formulas that X bar is equal to D by 2, we got 25, Y bar is equal to H by 4, we got 25 centimeters, and Z bar is equal to D by 2, we got 25 centimeters. So, now how to write the center of gravity of this given solid cone? The center of gravity of given solid cone is G of, this is very important point here. In the previous problems, determination of centroid by simple figures, composite figures, shaded regions, we represent C of X bar comma Y bar. But now, determination of center of gravity of simple bodies, this is category 1. So, in this, the center of gravity of a given solid cone is G of X bar comma Y bar comma Z bar is equal to G of 25 comma 25 comma 25 centimeters. This is the ultimate answer of this particular given solid cone. Then we need to find one more parameter, which is called volume of this solid cone. Did you understood here? So, now the first one is solid cylinder, the second one is solid cone. Now, volume of solid cone, we have a standard formula. What is that? V is equal to 1 by 3 pi r square h. Bring the value of radius and height and substitute in this formula, we will get like this. That implies V is equal to 1 by 3 into 3.14 into. Here in this formula, radius is there, but we have given in the diagram diameter. So, my diameter is equal to how much? 50 centimeters. So, therefore, 50 by 2, how much it is? 25. Therefore, 25 whole square into height is equal to 100 centimeters. Okay. So, the respective values, once again I am telling here, my 1 by 3 into pi value is 3.14 standard value, and my radius is equal to 25, because in the diagram I have given my diameter is equal to 50 centimeters. If you divide r is equal to d by 2, we substitute 25 here. So, therefore, 25 whole square into 100. After simplifying this with calculator, we will get V is equal to 65416.66 centimeter cube. This is the ultimate answer of this given problem. Okay. So, this is the first category, that is determination of center of gravity of simple bodies. Similarly, for determination of center of gravity, we have another two parameters or another two categories, which is called composite bodies and shaded regions. That we will see in the next class. Thank you very much, students.